All right, finishing up what we had yesterday with respect to our notes. We started talking about normal distribution, and we had characteristics of normal distribution, and this is theoretical. As I talked about yesterday, you'll be responsible for giving me two of these on the next quiz. Give me characteristics of a normal distribution, and you can do any of the 7 or 8 that you have here. Last one we talked about yesterday was talking about the empirical rule. And in the empirical rule, if a set of data is a normal set of data, if it's a normally distributed set of data, 68% of the data will lie within one standard deviation of the mean. Well, how we translate that into what we're talking about here. If we would look at one standard deviation from our mean. Here's our mean, here's our X bar. This is our X bar plus one standard deviation. This is our X bar minus our one standard deviation. If we take a look at this area right here, this area is equal to 0.68. Now we know from one of our characteristics, the entire area of this bell-shaped curve, this entire area here is a value of 1. The entire area is equal to a value of 1. This area here, if I go one standard deviation either side of the mean, this area right here of the bell-shaped curve is a value of 0.68. If we go 2 standard deviations, from the mean, so this will be X bar plus 2 standard deviations, and this is X bar minus 2 standard deviations. If we take a look at this area now in blue, this area here under the bell-shaped curve is now equal to 0.95. So this entire area here that is in blue is 0.95. Once again, the entire area is equal to a value of 1. Then if I go 3 standard deviations, the entire area will be 0.997. Won't be exactly 1 because we're asymptotic there. We won't actually get to a value 1 and getting a specific value, but it'll be close, very close to a value 1. This is the basis that we will continue to work with and deal with now. The characteristics of a normal bell-shaped curve, and now we're talking about area. When we have a standard normal distribution, when we standardize a normal distribution, yeah, oh, my bad, I get you. Sorry about that. Yep. When we talk about normal distribution, we're just talking about the distribution of the data. When we standardize our normal distribution, this is a normal distribution with a mean of 0 and a standard deviation of 1. If this is a standard normal distribution, when we standardize things, well, the question is, how do we standardize things? We standardize things when we take a set of data and we turn them all into z-scores. If we take all of our data values and turn them into a z-score, This standardizes our set of data. And our z-score is something we dealt with at the very beginning of the class. Didn't really do much with it. We just defined it. Now, from this point on, we will be dealing with a lot of z-scores. Everything we do is going to be dependent on a z-score or what is called a t-score, which is very similar. And how we calculate a z-score, we take our value minus our mean and we divide by the standard deviation. Which is x minus mu divided by sigma. Or x minus x bar divided by s. Okay, the first thing I'm handing out here is the notes, because now what we're going to start doing is applying the idea of a z-score and a normal bell-shaped curve. The table that is there is called a z-table, but it's a little bit smaller. What I'm doing is giving you a second z-table. This is one that's a little bit bigger, a little bit clearer for you. It is something that we will be using for the entire chapter here. So it's something that you will readily want to be able to come up with and get to. There's numerous types of z-tables. This one I think is the easiest one to work with. So we're going to look at normal bell-shaped curves, but we're going to standardize these normal bell-shaped curves, which means we're going to look at the z-score. How we calculate that z-score is value minus mean divided by standard deviation. And once again, when we have a standardized normal distribution, when the set of data is all converted into a z-score, okay, when you standardize, when you turn all your data values into a standardized value or a z-score, you have a set of data values. You calculate the mean and standard deviation. Calculate the mean and standard deviation of an entire set of data. If you would take the average, if you would take the mean of all those z-scores, you add them up and divide by the total number of z-scores. What you should come down to is 0. What you'll come down to is 0. So when you standardize a set of data values, the mean is going to be a value of 0. Once again, something that you'll have to remember. The standard deviation of that set of data will be a value of 1. So if you go your z-score minus the mean, which is 0, and square that and divide by the standard deviation, or divide by your n, you're going to come down to a value of 1. And once again, how we calculate a z-score is your value divided minus your mean divided by the standard deviation. Now, as we talked about when we started with probability, probability for weatherman is the area that's going to be covered in rain. Tomorrow, you have a 100% chance of rain. Tomorrow and tomorrow night. And that spills into Saturday morning. Sorry, cross-country runners. You'll be mutters. When we talk about area, we talk about probability. What that 100% chance of rain means tomorrow night is the entire area will be rain. It will be raining in the entire area. You cannot go anywhere in Northeast Ohio where it will not be raining. Okay, that's what it means by 100%. The entire 100% of the area will be covered by rain. So when you talk about area, you talk about probability. And that's a key idea to remember here. That's a key idea to remember. Now, the Z-table that you have. Okay, the Z-table that you have. Once again, the only thing different between this Z-table and this Z-table is this is blackened in here. Okay, this Z-table here has the line with a Z-score and 0. What the Z-table will tell you, given a Z-score, the table will give an area. Given a Z-score, the table will give an area. And this area is going to be the area from 0 to the Z-score. So you're going to be given a Z-score. With that Z-score, the table that we have down here will calculate an area for you. You don't have to use 1/2 area of the base times the height. You don't have to deal with 1/2 base times height. You don't have to worry about pi r squared. You're not calculating the area that way. You don't have a formula to calculate the area. This table will do it for you. So if I have a Z-score, a Z value of 1.83, we have a Z-score of 1.83. If we take a look at this table, we have the Z values over here, which is a whole number and your tenths. So we have a whole number and a tenths. Along the top gives us the hundredths. So if I'm looking at 1.83, I can scroll all the way down to 1.8 and slide over to the 0.03. So I have the 1.8 line, and I go over to the 0.03 column, and I get a table value of 0.4664. Which means if I take a look at my bell-shaped curve, old tartar sauce. If I would take a look at a bell-shaped curve here, and you'll get used to doing these. Here is a bell-shaped curve. I have a 0 value and I have my Z-score of 1.83. I have 0 and 1.83, my Z-score. My table will tell me that this area right here is equal to 0.4664 squares. 0.4664 squares. That's the area. The area, once we start getting into problems with this, will also then take us right into a probability. If I have a data value, that gives me a z-score of 1.83, values of the z-score that are smaller than that if I look at my mean here and my data value, I have a 46.64% chance of having a data value in between those two values. It will also give you a probability because area equals probability. Once again, this z-table here is exactly the same as this z-table here. So when we go to the back, you don't have to sit there and flip-flop back and forth. Find the area between the z-scores of 0 and 2.0. Every time you do one of these problems, what is expected, just like what, oh, you haven't been in trig class yet. What is expected for you to do is to draw a bell-shaped curve. Pictures make these problems a lot easier. And once again, you'll get better at your bell-shaped curves as you go along. My z-value of 0 is right here in the middle. This is a z-value of 0. Think of this bottom here being a number line, where if I go in this direction, I am positive. If I go in this direction, I am negative. Okay, so think of it as a number line. I got a z-value of 2, which means it's a positive 2. I'm going to the right. So I'm going to the right. I'm going to put in a value of 2. So this is where z is equal to 2. We want to calculate the area between the z-value 0 and 2. So we want to calculate, what is this area right here? So now I go to my z-table. My z-table, once again, will give us the area from 0 to any z-score. So I can go down my left-hand column to 2, and this is 0.00. So I have 2.0, and I can go over to the 0 column and find my table value. What is our table value? Rachel, what do you get? 0.4772. So this area is equal to 0.4772. Okay, this is what you get from the table. Okay, 0 and 1.5. So we have 0 and positive 1.5. What's the area from 0 to 1.5? 0. Once again, I know these basic ones are a little bit easy. I don't need, I can just look at the table, I can find it. But when we get a little bit more complicated, the picture will help you try to figure out what value that you have and what you have to deal with. So if I go to 1.50, Jalen, what's your value? 0.4332. All right, These were very basic, but we have to start somewhere. Now we're going from -1 to 0.5. Once again, now we start getting a little bit more complicated. We have our 0 in the middle. My 0.50, I know I go to my right. My -1.0, that's going to now take me to the left. Okay, once again, think of this as a number line. Whoopsie. So I got two different areas. I get my table will tell me my area from 0 to a z-score. So let's go from 0 to 0.5. 0 to 0.50. Okay, so I look at my table, I go down to 0.5, I go over to the 0. Melanie, what do we come up with? 0.1915. So this is 0.1915. But the problem I run into, I don't see any negatives on here. How do I find a value for -1? Why is that? You're exactly correct, but why? You're going to take up the same area. What's the characteristic that we had? The graph is going to be what? What's the key word? Anybody? Symmetric. It's going to be symmetric. The graph is going to be symmetric. So if I go to -1.0, I also have +1.0. So I can go to +1.0 and get my table value. 1.00 table value is what? Maddie? 0.3413. I want to find the total area between these two values here. This is where a picture tells you 1,000 words, or maybe one word. What do we have to do with these two areas to find this total area? Add them. We have this area plus this area to get my total area. So we have 0.3413 plus 0.1915. Now, you don't have to write the values in here if you don't want. That's fine. But what I want you to do is I want you to show me what you're doing with your table values. Show me this, because sometimes you're going to be adding, sometimes subtracting them, sometimes adding it to 0.5, sometimes subtracting from 0.5. And if you have the wrong things, but you have the right table value, I can give you a little extra points then. If you have at least the right table value, but wrong operations. Ethan, what do you come up with? 0.4332. Okay, why don't you do the next one? We're going from -1 to +1.75. Check your answer with somebody around you. We have -1 and +1.75. I just make them a little bit bigger so I can write my areas in there. And check your answer with somebody around you. Ella, what did you get for the two table values? And then the other one? 0.45 what? 99. What are we going to do with these two values? Add them, and what do you come up with? 0.8012. Good with that? All right. Find the area to the left of the z-score of negative 0.5. Okay, we got our bell-shaped curve. We have our 0. We have negative 0.5. I want to find the area to the left of this z-score. So we want to find this area right here, to the left of the negative 0.5. Well, as we found out, my table tells me the area from 0 to my z-score. 0 to my z-score. Doesn't tell me this area over here, but I can find this area from my 0 to my z-score. What's the area from 0 to 0.5? From 0 to 0.5, what's our area? AJ? 0.1915? Is that what you said? All right, that gives me this area. Now the question is, how do I find this area over here? I can find this area. How can I find this?
Subtract 0.1915 from 0.5.
Well, where'd you come up with 0.5?
Because the whole curve adds up to 1.
The entire area adds up to 1. So this entire area adds up to 1, which means if I look at my symmetry, each side is going to equal 0.5. So this side over here, the area is 0.5. This side over here, the area is 0.5. To find this area right here, I can subtract this off. So I have 0.5 minus 0.1915. Once again, looking at a picture makes it a little bit easier to realize that what you have to do. So I have 0.5 minus 0.1915. Lucas, what do you come up with? 0.3085. Find the area to the right of the same z-score. So we're looking at the same z-score. Negative 0.50. I have the same z-score, but now I want this area here. We still found this with that z-score 0.1915 is that. Now what are we going to have to do to calculate our area? Plus, that's right. So we have 0.5 plus a 0.1915, so we have 0.6915. Once again, looking at a picture makes it a lot easier. What's the area to the right of the z-score of 1.23? Find your value, check your answer with somebody around you. We want to go to the right of 1.23, so we want that area. No. We're instructing. We're what? All right. First, find your Z table value, 1.23 for 1.23. And what do you have to do to find the area to the right of that? Okay, first off, we take a look at our table value for 1.23. Sarah, what's your table value for 1.23? 0.3907. So that is this area right here. Now we want to calculate the area to the outside of this, okay, which is very similar to what we did up here, calculating the area outside. So Sarah, what do we have to do? 1.23 Not 1.23. What's our entire area here? To the right. What's this entire 0.5? So this entire area is 0.5. So this entire area from here to here is 0.500. That's my entire area here. So what are we going to subtract our 3.907 from? 0.3907. There we go. I get it. Jade, what do we got to do here? So we have 0.5 minus 0.3907. So we use our Z value only to find our value from the table. So our Z table value, we just find areas from the table. Okay, we don't do anything calculation-wise with our Z value. We look at our areas and we do our calculations with the areas. Jade, what do you come up with then? .1093. All right. Now let's take a look at the worksheet I gave you. Let's go to the back. Take a look at problem number 14. Calculate the following probabilities. Okay, what we've done up till now, we've calculated areas. But areas is synonymous in statistics with probability. If I talk about area, I'm also talking about probability. They are the same. So if I'm calculating area, I'm also calculating probability. I want to know the probability that my Z value is between 1.2 and 2.1. So if I look at my table here, or look at a diagram, a bell-shaped curve, here's my zero value. I have 1.2 and I have 2.1. I want to calculate the area, this area right here. I want to be in between these two Z values. Once again, your Z table will give you the area from 0 to a Z-score. So if I look at 1.2 to begin with, 1.20, I go down to 1.20. What is our table value for 1.20? Skylar, what do you have? 0.3849. That is this area right here. .3849. If I look up my value for 2.1, 2.10, my table value for 2.10 is what, Justin? 0.4821. Bless you. Which is this entire area. 0.4821. The area from here to here is 0.4821. The area from here to here is 0.3849. I want to just calculate the red hash here. I want to calculate this by itself. So what do we have to do with those two areas that we just got from the table? Subtract them. Once again, it's a lot easier to see this with a picture, what you have to do. So we have 0.4821 minus the 0.3849. So we can subtract them. Once again, show me your table values and show me what operation you're doing with the table values. Because I have students that will add these, wrong operation. You had the correct table values, but if you just clickety-clack it through the calculator and give me one answer, it's either right or wrong. But if you perform the wrong operation, you took a value and you subtracted from 0.5 rather than add it to 0.5, at least I can see that you have everything correct except for the wrong operation. I get you some partial credit off of that. If you don't, it's all right or all wrong. Grayson, what do you come up with?
0.0972.
0.0972? Go with that. So this is the other type of problem that you'll run into. Okay? Sometimes you'll have to add the two values. Sometimes you'll have to subtract the two values. Sometimes you'll have to add the 0.5. Sometimes you'll have to subtract from 0.5. Okay? You drawing a picture will make it a lot easier for you to determine what you have to do. If you just try to visualize in your brain, you'll run into mistakes. It's just a lot easier for me to draw a picture and see it in the picture. Tells you what you have to do. Questions you have? All right, your homework for the weekend is just doing the worksheet here. Solutions have been provided for you. Once again, this Z table, have it somewhere so you can always pull it out and use it. I also attached the Z table to Google Classroom, so if you forget it at school and you need to work on this at home, you can pull a Z table off at home. You can always Google Z tables too, and a billion of them will show up. Not all of them will be the same now. Like I said, I find this Z table the easiest to work with. The other Z tables is too much. You have to overthink the other Z tables. Questions? All right, rest of the time is yours. About 5 minutes.